Do 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 do. I really like Jurassic Park, and all images are brought to you by my friend Alyssa. Her Instagram is in the description below if you are curious about anything she does. She's also who made my intro animation, so obviously I love her work, and she loves Jurassic Park. Like a lot. Like, I like Jurassic Park. I like the book, I like the movies. I think it was her first movie. So she sent me so much information that I will have down in the description below for different sites you can check out, things that I'll have been pulling from as I put together this video. But let's get into it. So today's science behind the magic. Can we make dinosaurs? Is that something we're capable of doing? I mean, that's what happened in Jurassic Park, right? If you don't know, Jurassic Park is the story about a bunch of rich white people who were like, let's bring back dinosaurs to make money because we can. So in that story, they talk about how they made dinosaurs, because back then, our ability to interact with the human genome was very difficult. We hadn't sequenced it yet. Manipulating it and cloning it was a lot harder, especially compared to today. Today, I personally manipulate DNA all the time. For my own personal research studies, I give it to high schoolers to work with. It's actually something that's really streamlined now. And in the past 5 years or so, maybe 5 to 10, we've gotten a really cool tool set that's really changed the game. I'm not going to go into the ethics in this video. I feel like the ethical questions that are behind DNA manipulation, bringing back extinct species, manipulating the human genome so that you can prevent diseases, it's very complex. It's not a black and white space, and I don't feel like I am an expert on that, although it's always intrigued me. Today, I'm just going to talk about what we can do, what we are doing, just the science behind it, and you're welcome, to share your thoughts about it in the comments below, and we can maybe have a nice, mature discussion about the ethics behind this science. So the first thing I want to talk about is this is a lot easier to talk about in the context of mammoths. So this isn't, dinosaurs, but this is something that's more in our wheelhouse. And they actually are working to bring back a certain mammoth species because it would be beneficial to climate change and the ecology of the northern tundra regions to have this species back. And so the idea behind this is you have I believe it's the Asian elephant, and they have a very similar genome to the mammoth, and we still have access to mammoth DNA because they passed away not as long ago as the dinosaurs. And what you can do is I will have an image here. I'll make it half the screen or something like that, where you can manipulate the Asian elephant's DNA to insert the traits and portions of the mammoth DNA that make it a mammoth. So its size, how it, its fur, so like how it adjusts to the climate of the cold tundra. So you first, as a scientist, have to figure out what genes relate to what traits. But once you know which genes are mammoth genes and how they replace the Asian elephant genes, you have to edit the genome. And this is where we have cool tools. This is where, if this was even like 10 years ago, it would be much more complex, maybe doable, but now we essentially have a cut and paste tool. The Control X, Control V, we have that for DNA, and this is through what's called CRISPR-Cas9. CRISPR is a really long name. We're not going to talk about it. It will make no sense. It makes no sense to me, so we're not going to. But the idea behind this tool, and you can kind of see it in this image, is you can have RNA. So if you don't know, RNA is a nucleic acid, which our genome is in our DNA. That's what's in the nucleus of our cells. That's the house, the library of our genes. In order to make proteins, in order to make the bits that are us, DNA needs to be translated into RNA, and then that RNA is translated into proteins. So with CRISPR, we can make an RNA guide. This RNA guide will target a certain sequence in the genome of interest. So in this case, we want to change maybe the skin texture of the Asian elephant, so we have a tag to that target sequence. It also will attract an enzyme. So enzymes are machines that do a specific task. Specifically in this case, this enzyme is going to cut. So the enzyme will come to where the sequence has been targeted, as you see in this picture, and then you see the scissors, it's going to chop away. And with some other tools, we can then either just remove a segment, so maybe we just need to turn something off, knock out a gene and be like, okay, just don't do this anymore, go back to default settings. or we can then repair it. And in repairing this gene, we can add in our gene of interest. So maybe making the mammoth furrier again has its own gene. And this is something we're working on right now. It's something that we can use all the time in labs, and it's being streamlined into kits. I haven't used one personally yet because all my tools still work and are still quick and easy. But it makes it possible that you can foreseeably bring back a species. Now, let's extrapolate this into dinosaurs because, right, dinosaurs. Unfortunately, we don't have any viable dinosaur DNA. It's not like in the movie where we have like this mosquito and it has the blood and the DNA is still there. DNA is a very sturdy nucleic acid. Like, it takes a lot to break down, but it's still been millions of years. So it does happen. UV lights are very harmful to DNA. It will break it down and destroy it. But what we can do, which if you don't know, dinosaurs are closely related to like birds and chickens and things like that. So what we can do is using the bird's DNA or their genome, we can kind of make a dinosaur-like embryo. So we can make a dinosaurs-like species, but it won't be a specific species. Like, we're not going to be making a T-Rex or a Triceratops or a Brachiosaurus, all those things. But we can make something that mimics what a dinosaur might be, like engineering our own type. A little bit too close to Jurassic World maybe, but something like that. Now, should we? Do I believe we should bring back dinosaurs? No. No, I don't. Because we don't have a climate that's conducive to them. It's a completely different world. They are huge. Like, they're such large energy resources. Like, even if you only had plant-eating dinosaurs, they would eat all the plants, or that's what my brain thinks. I haven't done the math or anything, but I just feel like then your cows don't have the plants, and like our whole like food chain is based around cows, like getting food for the cows, and I don't know. I'm not a nutritionist, but I just feel like we shouldn't have dinosaurs. But it's interesting how close we are to being able to. And so I'm going to leave down below, there was this TED Talk for the dinosaurs thing, the website about the mammoths, and a CRISPR-Cas9 information down below. Feel free, as always, to ask me any questions you have. I am always happy to talk about these things. And if you have any suggestions or requests for the next Science Behind the Magic, feel free to comment those as well, or reach out to me on Instagram or Twitter. And otherwise, if you don't have anything to say but want me to know you're here, leave an emoji or say dinosaur. And like if you liked it, subscribe if you want to, and I will see you in the next one. Bye.